These are position vectors. The first kinematic property that we have to define for the pin O, that we call position vectors. This one using a vector notation. So if we want to use a vector notation, for Cartesian we have the unit vector I and unit vector j. For cylindrical polar we can use unit vector ER and E theta. In the book normally they don't use this E theta. I just add this angular position so that I know the angular position for these vectors. Just now we look at the pin O, and then we give the solution, the kinematic properties of pin O. Dalam ujian, you can give only this solution. Satu solution is correct. Or you don't want to use Cartesian, you want to represent by cylindrical polar. This one is also correct. So if you have only you want to represent as a S coordinate system, is also correct. You don't have to write all of them. You just pick the one that you want. Here I just add that this position is fixed. So for all time t, dia tak move. It's so fixed because we have this ground schematic diagram presentation. And then we look at the dynamic properties. The dynamic properties kat sini. What is the dynamics? Dynamics mean those related to force. Normally, we have unknowns. Unknowns here, and then in terms of the direction or component that's suitable to represent the forces. For example, for pin O, we don't know whether is this the direction of component of the forces acting on pin O. So we don't have any information about it. And then the reaction force here, reaction atau nak panggil force pun boleh, panggil reaction force pun boleh. So we have reaction which is 0 subscript x and O subscript y, because this O represent the pin O, and then it has the direction of x as well as y. So we are going to use the Cartesian coordinate system to represent or to describe the dynamic properties. So dynamic property is a general name, a specific name refer to the force. Another example for dynamic properties is the moment. Moment is another dynamic properties. Weight, right? So that is another example of dynamic property. For R, so if we want to represent, if you choose the cylindrical polar coordinate system, this one is represented by the cylindrical polar coordinate system. Have the component of reaction force at O in R direction or in theta direction, and they are always in the perpendicular to each other. So this one is 90 degree, this one is also 90 degree, something like that. Now case 2. So the first one yang tadi tu kita pusingkan manually, maybe the next one we look at the another electric method to rotate the pin, right? So we attach the pin, and then we have a coupler there, and then we have electric motor. This electric motor we rotate the system, right? The pin. So we are using the same Cartesian coordinate system, and the angular motion is represented by theta, right? Macam mana nak dia theta ni? Ni Greek punya letter theta. Symbol that normally we use to represent the position, and time derivative of position will be the angular speed. You can use a theta dot. This one represent theta per dt. We assume that the theta is only depends on the time, or you can represent by omega. These are the Greek letters. This one also represent angular speed. And then we have the second derivative of the angular position, theta dot with a 2 dot there top of it, or alpha. So this one represent the angular acceleration. The angular speed, the unit is this one is radian per second. Radian per second power of 2. This one is radian per second. This value will be positive in counterclockwise direction. So what does this mean? The system move in counterclockwise direction. Kalau katakan sini positif, the angular acceleration is positive with the direction of motion. So it means that the system is accelerating. But if this one is positive, but the angular acceleration is negative, what does it mean? It means that the system is decelerating. So angular direction tu dia slowing down, walaupun dia positif. And if the direction is negative, it's counterclockwise direction, and this one is positive in that direction. So it means that the system is slowing down. Now for all t, right? This one is for dia punya walaupun you ada dia punya position macam tu, right? You have a different case, we have electric motor, but the position vector remain the same. So we just concentrate on that particular pin only. We don't want to know what actually happened, what caused that the pin to move, the linkage to move, something like that. It's not our interest. So in dynamic, we're going to exclude part which is not really concerned to the kinematics and dynamics of the rigid body. This one is not a rigid body. This one is a model of particle.